Hello everyone, I'm back with another question. Largest local value in a matrix. In this question, we are given an n cross n matrix that is nothing but a square matrix. In this example, we have a 4 cross 4 matrix and we have to return a matrix of size n minus 2 cross n minus 2. As we see in this example, we have written a matrix of 2 cross 2 because 4 minus 2 is 2. Now, a max local is defined as the largest value of the 3 cross 3 matrix in the grid centered around I plus 1 and column j plus 1. What does that mean is for any I cross ij, that is, let's say for this ij, the center will be I plus 1, j plus 1 in the next row and in the next column. So that would be in this row and in this column. So that would be this 5. So we can say that for any matrix, the center will be the diagonal element, the next diagonal element to that element. For this 6, it will be this. For this 9, it will be this 6. So the max local value is the maximum value in the matrix that is centered at this element. So if we see this matrix, so that will be nothing but this matrix, and the maximum element that we can see is 9. So that is why we have here 9. And now for the next element ij, that is for this one, the matrix will be centered at this, and again the maximum value will be 9 because you have a 9. And now what we can do is we can go to this 8, but the matrix centered here will not be a complete matrix, so we won't consider it, and that's why we just have to return the matrix of size n minus 2 and n minus 2. So you don't go any further. Okay. And now we'll move to this element. For this element, the matrix will be here. And the maximum element that we can find is 8. So that's 8. And now, finally for this element 6, the matrix will be centered around this one. And the maximum element is 6. That's why we have a 6. Now, how are we going to solve this problem? It is an easy question and we can solve it directly with the brute force approach. That is what we have done till now. What we have done is, for every element, we find the matrix centered around that. So, if we look at it, it will be just a 3 cross 3 matrix. That's first element will be the element that we are starting. Okay. So, for this 9, that is for this 0, 0 elements in tree, the matrix will be starting just here. And for this element, we just need to traverse this matrix and find the maximum element in it. And now we move to this element. Then we have a matrix starting from this element of 3 by cross 3. That will be this one. And the maximum element we'll have to find by traversing each element. So the complexity would be, as it is just a 3 cross 3 matrix. So for checking the maximum element, we are just going to check 9 times, 9 elements, and we check this 9 elements for every element in the matrix. That's not for every element, but for these many elements, or the size of this n minus 2 cross n minus 2. So that's nothing but n minus 2 square, and that's for every element, so 9 will be multiplied, and that will be nothing but O of n square. And we have to return an answer matrix, so the space complexity will also be O of n square because you are going to make a matrix of n minus 2 cross n minus 2. Now let's move on to the pseudocode of this problem. You will be able to write the code yourself. It's really easy. And if you need help with the code, you can find the links in the description. So now, first of all, we will traverse the matrix, but before that, we'll just declare an answer matrix that we have to return. So let's say this is our answer matrix. We'll make this answer matrix first, and its size would be n minus 2 square, n minus 2 cross n minus 2, make the matrix. Now, you have to traverse this matrix. And to which element you are going to traverse it? You are going to traverse it, not all the columns and all the rows, but before n minus 2, that is just here, not full. So we will say for I in row minus 2, and then for j in column minus 2. Now here row and column are same, so you can just replace it by n. And in these two loops, for each element, you have to find the maximum element of the matrix starting there. What it means is that for this element, now if our I and j are both 0, then we are at this element. So we need to find the maximum element in this matrix that is starting at this element. And for that, let's use a helper function. So we will write the helper function, but for now, assume that the helper function returns the maximum value in that matrix. So we will just say that our answer matrix, and its I, j, is equal to our helper function that will take the argument of grid, this current I and current j, because from here we want to start, so we need to tell the function from where the matrix should start. And now our answer matrix will have this answer, and we finally just return this answer matrix. But let's see the code of helper function now. We know that we need to traverse a 3x3 matrix. So in the helper function, let's just make two loops which are just traversing a 3x3 matrix. So that would be for, let's say we have used I and j here. So let's use variable like a and b. So for a in 3, because let's say 0 to 3, and for j in 0 to 3. That's how we'll traverse a matrix of 3x3. And in this loop, we'll have to find the maximum element. So let's have an variable in answer and initialize it by 0, because the minimum element can be 1 because of the constraints. And now answer is equals to max of answer comma grid. And now which element? We can't just say grid of, this should be b, not just grid of a comma b, because that will always be 0, 3. You have to give them offset where you are starting. So that would be grid of a plus I and then j plus b. So this would give you the elements, like for example, if you are here, so let's use different color. So the coordinates of this one will be 0, 1, 0, 1. So that would be 1, 1. And now you have to traverse this matrix. So our loop is the a and j, a and b are going from 0, 1, 2, 3, 0, 1, 2. They won't go 3 because that will be less than 3 because of the indices. Now, for this element, if we add the offset, that is 1, 1. So in A you are adding 1, and in B also you are adding 1, because it's 1, 1. If it was an element like this 0, 1, this element 1, 0, then you would be adding 1 here and 0 here. Now what would happen is, what are the indices that it's going to give you? It will be 1, 2 and 3, and it will also be 1, 2 and 3. And now if you look at the coordinate of this matrix, you are going to get the same, because that would be 1, 1, 2, 2, 3, 3, and this would be 2, 2, 2, 2, 2, 3. This will be 3, 1, 3, 2 and 3, 3. And those are the matrix that these values are going to give you. So that's all for this video. I will catch you in the next video tomorrow. Bye bye. I hope that you have understood this video. If you have any doubt, the open is the comment section. So goodbye.